Hello students, in the last class we discussed about few important concepts related to heat and temperature, definition of heat energy, its SI unit as well as definition of temperature and various scales in order to measure the temperature and formula to convert the temperature from one scale to another scale and few important problems also. We discussed a few important questions also related to that particular concept. So in this section we are going to discuss about other few important concepts related to the same chapter, heat and temperature. So we all know that matter exists in our nature in how many types? Three types. Three types of matter are exists in our nature. First one is solid and the second one is liquid and the third one is gaseous state. Solid possesses definite shape as well as what? Volume also, while liquid as well as gas possesses definite volume only. Usually liquid will take the shape of the container only. So solid possesses definite shape and size also. What's the reason? In case of solids, intermolecular force of attraction is maximum. Solids possess maximum intermolecular force of attraction and hence solids possesses definite shape and size also. But in case of liquids, the intermolecular force of attraction is less, while in case of gases, the intermolecular force of attraction is very less. The gas molecules are randomly moving and hence the gas do not possess particular shape. So here in this the picture you can observe a thermometer is placed in a particular liquid. Usually thermometer is a device which is used to measure the temperature of a given substance. So if it is a hot liquid, then its temperature is more, otherwise its temperature is less. Next here a glass containing some water. A glass containing some water is placed on the gas burner. So that a thermometer is also placed inside the glass beaker. So as the liquid gets heated, then what will happen? The temperature is increased. That can be recorded by using a thermometer. Next, the change of physical state of matter. So when heat energy is supplied, two things are possible. Either there will be increase in temperature or there may be a change in state. So when liquid is heated after 100 degrees Celsius, then what will happen? It starts to evaporate. That means there is a change in state from liquid state to which state? Vapor state. Similarly, in a beaker, a thermometer is placed. If it contains some water, if you put some hot substances on that particular beaker, then what will happen? Its temperature gets increased. Next, expansion of solids. So there is a iron wall. Initially it can pass through the ring before heating. After heating, what will happen? It cannot pass through the ring. That means there is a expansion. Expansion in solid because of what? Heating. So in this picture you can observe some amount of water which is at ordinary room temperature is poured on the liquid nitrogen. There you can observe the mist which indicates the rate of evaporation of the liquid nitrogen increases as you pour the water. Next, production of heat and light. So it is possible to convert energy from one form to the other form. If a coil is heated, then what will happen? It produces heat. At the same time, it is possible to convert electrical energy into what? Heat energy. Electrical energy into light energy. So change of resistance in case of what? Conductors. So as the temperature increases, the resistance of the metal or a conductor usually increases. Next, heat triggers the chemical reaction. Actually, fire is a chemical reaction between the oxygen in the air as well as some fuel. So because of the chemical reaction between oxygen present in the air and some fuel, what will happen? The fire will be produced. Next, when you place the disperine in water, the rate of chemical reaction usually increases. So because of the organic effect comes from the mixture of heat and some chemical reaction which leads to the formation of some beads as shown in the figure. Next, few consequences of expansion in case of solids due to the heating. So usually in summer season you can observe the expansion in case of railway tracks, thermal expansion of long strips of metal. So telephone wires are hung loosely. Reason why? Usually solids expand on heating as well as what? Contracts on cooling. So in winter the wire gets contracts because of the decrease in temperature. Because of that reason telephone wires are loosely hung in order to allow the contraction during the winter. Next, how can you fix the iron ring? So in a wooden cart, so first the iron ring contracts when it is cooled and it grips the wooden cart will tighten. Next, usually glass contracts on heating as well as what? Cooling also. So we know that the material expands on heating as well as it contracts on cooling. Because of that reason, what will happen? The glass gets cracked. Next, the bursting of tire or rupture of what? Tires as well as what? Tubes. This is because of what? So if it is an uninflated tire, because of the friction, what will happen? It produces the heat, and because of the reduced temperature as well as what? Pressure, which will cause the rupture of what? Tires as well as tubes. So when heat energy is supplied, two things are possible, as I said earlier. One is there may be a rise in temperature, or there may be a what? There may be a change in volume, or there may be a what? Change in state of the substance. So what do you mean by expansion? The increase in volume without any change in state. The increase in volume of the substance without any change in state is called as expansion. All the three states, solids, liquids as well as what? Gases can undergo expansion. Expansion is least in case of what? Solids, and it's maximum in case of what? Gases. The reason why? In case of solids, the intermolecular force of attraction is maximum, and in case of gases, the intermolecular force of attraction is very less, and hence the gases will undergo expansion to a very large extent. Solids can have three types of expansion. Solids can undergo area expansion, linear expansion as well as what? Volume expansion. So first one, linear expansion in solids. So when heat energy is supplied to the solid, if its length is increased, then that type of expansion is called as linear expansion. Otherwise, when heat energy is supplied to a solid, if its area is increased, then it is called as area expansion or superficial expansion. Otherwise, due to the supply of heat energy, if the volume increases, then that is called as what? Volume expansion. So there are three coefficients corresponding to the three types of expansions. First one is coefficient of linear expansion, that is nothing but alpha. How can you find out the coefficient of linear expansion? So first, change in length is directly proportional to the original length. Here in this equation, delta L represents the change in length, that is directly proportional to the original length. Original length is L0 into change in temperature, that is delta T. So in terms of a constant, you can write that equation as delta L is equal to alpha into L0 into delta T, where alpha is a constant which is called as coefficient of linear expansion. Therefore, coefficient of linear expansion alpha is given by delta L by L0 into delta T. That is called as coefficient of linear expansion. So here in this case, there is an increase in length only. This type of expansion in solids is called as linear expansion. Second one is area expansion. That means due to the supply of heat energy, area of the solid gets increased. So here beta represents what? In this case, beta represents the coefficient of area expansion. Here delta A represents the change in area. The change in area is directly proportional to the original area, that is A0 into change in temperature, that is delta T. So all these terms can be combined by using a constant, that is given by delta A is equal to beta into A0 into delta T. So here alpha and beta, how they are related? Alpha is to beta is to gamma is equal to 1 is to 2 is to 3, or alpha is to beta is equal to 1 is to 2, or alpha is equal to beta by 2, or beta is equal to 2 alpha. Therefore, instead of writing beta here they will write 2 alpha. Therefore, delta A by A0 is equal to 2 alpha into delta T. Similarly, If the volume of the solid increases due to the heating, then that type of expansion is called as volume expansion. Here, in this case, delta V represents the change in volume, that is directly proportional to the original volume V naught into delta T, where delta T represents the change in temperature. So in terms of constant, you can write it as delta V by V naught is equal to delta V is equal to gamma into V naught into delta T. As I said earlier, alpha, beta and gamma, they are related as 1:2:3. Therefore, instead of writing gamma, I can write it as 3 alpha. Therefore, delta V by V naught is equal to 3 alpha into delta T. So that means here the material can undergo, solids usually can undergo linear expansion, area expansion as well as what? Volume expansion. Next, gas laws. So gas laws are the laws which relates the pressure, volume and temperature of an ideal gas. The gases can be classified into two categories. One is the ideal gas and another one is the real gases. Ideal gases are the gases usually obeys the gas laws, while the real gases are the gases which are actually present in our nature. So ideal gases are actually does not exist in our nature, only the real gases exist in our nature. So ideal gases are the gases which are not real, while the real gases are the gases which are actually existing in our nature. So first gas law is called as Boyle's law, which gives the relation between the volume and the pressure. How they are related? Volume is inversely proportional to pressure, which means as the pressure increases, volume decreases. Similarly, you can write P is inversely proportional to V. As the volume increases, pressure decreases. So graphically you can observe it. As the pressure increases, there will be a what? Decrease in volume. So if you consider two different gases, then you can write P into V is equal to a constant. Product of P and V is always equal to a constant, and hence you can write P1 into V1 is equal to P2 into V2. Second law is called as Charles' law at constant pressure. Out of three variables, pressure, volume and temperature, if the pressure is kept constant, at constant pressure, the volume of a given mass of a gas is directly proportional to temperature. That is the statement of Charles' law. Charles' law gives the relation between the volume and the temperature. I will repeat once again. At constant pressure, the volume of the given mass of a gas is directly proportional to temperature. V is directly proportional to T, or V1 by T1. V by T is equal to a constant. V is directly proportional to T. V by T is equal to a constant. If you consider two different gases, then you can write V1 by T1 is equal to V2 by T. Next, Gay-Lussac's law. This law gives the relation between the pressure and the temperature when the volume is kept constant. Where at constant volume, the pressure of a given mass of a gas is directly proportional to temperature. That is, P is directly proportional to T. Or P by T ratio is always kept constant. Or if you consider two different gases, then you can write P1 by T1 is equal to P2 by T. So ideal gas equation is nothing but perfect gas equation is given by PV is equal to nRT. What is this ideal gas equation? So the relation connecting pressure, volume and temperature of a given ideal gas is called as ideal gas equation. That is given by PV is equal to nRT, where P is the pressure, V is the volume, T is the temperature, and R is a constant which is called as universal gas constant, where R is an universal gas constant, where N represents the number of moles. So this is the relation which connecting pressure, volume and temperature of an ideal gas. But we all know that ideal gases are actually does not exist in our nature. The gases which are actually existing in our nature are called as real gases. So the real gas equation is given by a scientist named Van der Waals. Van der Waals equation is given by P plus A by P plus A into N by B whole square into V by N minus B is equal to RT. This is called as Van der Waals equation. Next, similar to the solids, liquid also undergo expansion. So liquids also undergo expansion to a larger extent when compared to the solids because of lesser intermolecular force of attraction. So there is one very important phenomenon in the case of expansion of liquids, that is anomalous expansion of water. So in all the other liquids except water, as the temperature increases, volume increases. As the temperature increases, density decreases in all the other liquids except water. But in case of water shows an exceptional behavior. In case of water, as the temperature increases, volume decreases. As the temperature decreases, density decreases. This is an exceptional behavior. As the temperature is decreased, you will see that density of the water is maximum around 4 degrees Celsius and its volume is minimum. This phenomenon is called as anomalous expansion of water. The density of the water is maximum and volume of the water is minimum at 4 degrees Celsius. This is called as anomalous expansion of water. Next, consequence of anomalous expansion of water. Here you can see that there is a formation of ice on the surface of water, but below the ice still there is a state is present in what? In which way? In liquid way, in water way only. So water pipes burst out during the winter. So usually you will observe the water pipes goes bursting during the winter season. This is because as the temperature is decreased, cold temperature results the things to contract. Ice has more volume than water, so when water freezes inside the pipe, it expands and increases the pressure inside the pipe, which leads to the bursting. So what will happen? As the temperature reduces inside the pipe, water gets converted into ice. Ice occupies larger volume when compared to the water, so it undergoes expansion, which increases the pressure inside the pipe, which eventually leads to the bursting. Next, so this is an example for what? Consequence of what? Anomalous expansion of water. So beneath the ice there is an what? Presence of aquatic animals. This is possible only because of what? Only because of anomalous expansion of water. As the temperature is reduced from 4 degrees Celsius to 0 degrees Celsius, what will happen? Hot water moves from surface to the downside, and hence what will happen? When the temperature is still decreases, what will happen? Ice formed on the surface of the water at first, but below the surface, what will happen? There is a layer, water exists, and the temperature is 4 degrees Celsius only. Because of that reason, there is a presence of what? Aquatic animals. Next, summary. So effects of heat. So there will be rise in temperature, as I said earlier. When heat energy is supplied, what will happen? So there may be a rise in temperature, increase in temperature, and when heat energy is removed, what will happen? The temperature will be decreased. Otherwise, expansion and contraction of matter. So all the three states, solids, liquids and gases, undergoes expansion when they are heated, and they undergo contraction when they get cooled. Change of physical state of matter. So usually when heat energy is supplied, there may be a rise in temperature or there may be change in state of the matter. So for example, when you supply the heat energy to ice, it gets converted into water, but the temperature remains same, 0 degrees Celsius only. So during the change in state of the matter, temperature remains same. During the increase in temperature, the state will be remain same. For example, when the water is heated from 0 degrees Celsius to 100 degrees Celsius, from 0 to 100 degrees Celsius, temperature only increases, but it present in liquid state only. But once the 100 degrees crossed, then what will happen? It gets converted into steam. So there may be a what? Change in state from liquid state to gaseous state. Next, evaporation. As I said earlier, when the temperature is increased beyond 100 degrees Celsius, what will happen? So water gets changed into which state? Gaseous state. Production of heat and light. It is possible to convert energy from one form to the another form. So heat and light can be produced. Next, an increase in rate of chemical reaction. You will observe organic effect, fire and explosion, as well as important phenomenon, that is anomalous expansion of water. So distinct behavior of gases under constant temperature, pressure, as well as volume. So you discussed about the gas laws, that is Boyle's law, Charles law, as well as Yale's law. Thank you.